Good morning, everybody. Thank you all for being here. It's great to have you with us. I'm a volcanologist in the Department of Earth and Environmental Sciences at Manchester, and I currently teach first and third year students in the geology pathway of our degrees, including the field trip to Sicily in the third year. My main research focus is the study of volcanoes and their gas emissions. The Earth is home to hundreds of volcanoes, dozens of which are constantly emitting gas, even when they're not erupting. And measuring these gas emissions is one of the most important elements in modern volcanology. So ultimately, life on Earth, our very existence, depends on volcanic gas. The origins, the oceans and the atmosphere, those features of our planet which make it habitable, are the result of a buildup of vapors released by volcanic activity over geological time. So even today, volcanic emissions and eruptions can modify our climate. To understand the long-term evolution of our planet, or our planet's atmosphere, we need to study modern-day volcanism. With dozens of active volcanoes around the world, how do we approach this? Cornerstone of our approach is to use satellite observations, which are global in their scope and can be made very regularly. Some of Earth's most active volcanoes are in the Southwest Pacific, including places like Papua New Guinea and Vanuatu. Satellites allow us to detect and accurately map the sulfur dioxide gas emissions of these remote volcanoes, as shown here in this image, where the warmer colours signify the highest concentrations of volcanic gas in the atmosphere over each volcano. In Manchester, we're currently working on new computer algorithms to automatically and in near real time calculate the gas flux from individual volcanoes anywhere in the world through the exploitation of satellite observations. Real-time measurements of gas emissions are also essential to understand the level of activity at any given volcano and form the basis, along with other data, to make forecasts or predictions of volcanic eruptions. Early warning of eruptions is essential. Over 500 million people worldwide live in the shadow of threatening volcanoes, and few regions are entirely free of risk. You may recall the disruption to European economy and air travel caused by the 2010 eruption of the Icelandic volcano Eyjafjallajökull. Gas emissions are one of the key parameters we measure to gauge volcanic unrest. But at many volcanoes, the level of risk is too great for we volcanologists to climb to the crater and make our measurements. So in recent years, we've begun to use drones, or unoccupied aerial vehicles, given their full title, to carry our sensors into the heart of volcanic gas plumes, often from several kilometers away, making direct measurements of the gas chemistry, or even bringing samples back that we can then analyse in the lab back in Manchester. And this is footage from a recent large collaborative project I've been involved with at Manam volcano in Papua New Guinea, a steep, highly active and otherwise inaccessible volcanic summit. So bringing our research right into the classroom is I think, a really big motivation for all of us. For me personally, one of the things I love is to be able to show students data from any volcano on the Earth. Volcanoes are remarkably diverse phenomena, and engaging with global satellite data is a great way to discover and learn about this complexity. So the coverage of our satellite data sets is growing at unprecedented rates. That's not just gas, but maybe measurements of thermal emissions or ground deformation, the dispersal of volcanic ash in the wind. Much of the data is open source. That is freely available online, and much of the software that we use to analyse or visualise the data are increasingly freely available and user-friendly too. So in a third year practical I taught back in March, we had students comparing the thermal and gas emissions from volcanoes in different styles of eruption in Hawaii, in Iceland, in Central Africa, reconstructing the course of these eruptions using multi-parameter satellite observations and research-grade software tools. An aerial view of volcanoes gives an unrivaled perspective on their landscape. So we run a popular field trip to study Italian volcanoes in Naples and Sicily. Unfortunately, this year it was cancelled due to the COVID pandemic. But as part of the virtual field trip we delivered to students, I put together movies of aerial observations of different volcanic landscapes taken from my fieldwork around the globe. So although we didn't get to see and climb all over the classic eruption deposits that, at Vesuvius that buried the Roman town of Pompeii, I could show a contrasting suite of volcanic landscapes around the world and get the students to think about the processes that form these landscapes, the risks to surrounding populations and infrastructure of these volcanoes which erupt again today. So fieldwork is integral to what we do, and I'm not at all suggesting a virtual approach should be replacing that. But in years to come, I think we're going to have great value in combining our traditional methods of teaching with a host of new approaches. That's all I wanted to say, but I'm very happy to field any questions that you may have. So thank you.